Hi everyone. In this last part of the introductory topics, we will focus on the different trigonometric functions. And to start off with, we will examine in this particular video the cosine function. Okay, so the cosine function corresponds to the x-coordinate of points that lie on the unit circle. It's understood that the cosine therefore depends on the angle of reference, and we can write x equal cos of theta. If you recall, in a previous section we introduced the unit circle, which I have highlighted here on the right hand side, with the different angles presented in radians. You'll notice that the cos of 0 is 1 because the x-coordinate of the point is 1 at angle theta equals 0. When it comes to pi over 3, the cos of pi over 3 is a half, because once again, if you focus on the x-coordinate, you'll see that 1/2 is what is revealed. Likewise, cos at pi over 2 is 0, because the x-coordinate is 0 at pi over 2. 7 pi over 6, the x-coordinate is minus root of 3 over 2, etc. One can observe that the cosine function is positive when the reference angle is either in the first or the fourth quadrants, whereas it is negative if we are located in the second and third quadrants. Here are some other characteristics that you can observe about the cosine function. So first of all, cos of theta and cos of theta plus or minus 2 pi will be equal to one another, because obviously the x component remains the same when full rotations are applied. And 2 pi, one way or the other, will generate a full rotation. Cos at minus theta and cos at theta are equal because the x component is symmetric with respect to the x-axis. Now the graph of the cosine function can be obtained if we sketch the values of cosine in terms or as a function of theta, which we will treat as the independent variable. Okay, so for all the different angles theta that we can observe in the unit circle and full rotations that follow or precede it, then the cosine values will oscillate as shown in the picture. Features that you can keep in mind when observing the graph of the cosine. So the domain of a cosine function is R. Its range goes from -1 to 1 inclusively. In other words, the maximum value a cosine will attain is 1, and the lowest is -1. The amplitude is 1. Now, the amplitude represents the displacement from the average value. So you notice that the cosine oscillates above and below 0. The furthest it goes above is 1, the lowest it goes below is -1. Period is 2 pi, which means the curve is repeated every 2 pi radian. As for all other functions we've seen in the past, the notation that accompanies the cosine function can be altered. The variables that are used can vary. For example, it's quite acceptable to write y equals cos of x, where now x will play the role of the angle and y will be the result of the cosine function. So don't confuse the x and the y in this expression with the x and the y coordinates of the unit circle. It's simply implied that in this case x plays the role of the angle or the argument, and that cos of x, the result of cos of x, is denoted by y. When it comes to modifications to the cosine function, we can submit the cosine function to the usual transformations we've seen before: horizontal and vertical translations, reflections, horizontal and vertical compressions or stretches. So in a more general format, a cosine function could be expressed as y equals a cos of b times x minus h plus k. Now obviously the graph of this function in its more general aspect, will differ slightly from the basic cosine we presented earlier. The absolute value of a is the amplitude of the curve. So the basic function will be compressed if the value of a is between -1 and 1, whereas it will be stretched, so it will oscillate further from its average or its median value if the size of a, positive or negative, is bigger than 1. Note that if a is less than 0, the basic cosine function will also be flipped, so there will be a reflection across the x-axis. The mins will become maxes, the maxes will become mins. 2 pi over b will generate the period of the cosine curve. H will generate a horizontal translation, so like usual, a positive value of h will mean a translation to the right. A negative value of h will be a translation to the left. K will generate a vertical translation, so positive value will move the curve up and negative will move it down. Here's some advice when it comes to drawing a graph that has been presented in a general formula. Okay, because obviously we've got these a, these b's, and the h's and the k's. So maybe just to give a little bit of structure, here's how we can draw a cosine graph in its general format. So I would suggest first and foremost drawing a horizontal line at height y equals k. So the k, remember, is the vertical shift. So y equals k will correspond to the average value or the median value of your cosine function. So oscillations will take place above and below this line. Draw two other lines, one that is absolute value of a above or below. So recall that the absolute value of a is the amplitude. So essentially it's the displacement above and below the median value. So everything will take place between these two bounds. Place the new initial point, taking into account the horizontal translation and the necessity to flip if the a is 0. That's a little bit complicated, but we'll examine it again. We'll look at an example later on. Use the fact that the period is 2 pi over b to plot points at the same height as the initial point. So everything will be repeated every 2 pi over b. For cosines, maximums, minimums, and even the median points are equidistant. So we'll generate kind of a repetition mode by using the period we calculated previously in order to draw our graph. So if you're set, we're going to try an example here. So y equals 4 cos of pi x minus 1 minus 2. Okay, so first of all, minus 2 plays the role. I'm going to just go slower here. Minus 2 is the k value. So notice how the first thing that I've drawn is a horizontal line at y equals minus 2. And oscillations will take place above and below this line. The amplitude, a, is 4, actually the value, absolute value of the amplitude is 4, which means that from minus 2, the oscillations can go up or down by 4, and I will draw these two other lines. So 4 units above minus 2 and 4 units below minus 2. So that's kind of a guide. So here in this example, the graph is already shown, but keep in mind if you're starting from scratch, you would have the median line or the average line, and you would have the max and the min lines to guide you. Now the h and the k values, so the h value in this case is 1. Notice pi times x minus 1. So 1 is where the maximum value will be. If you recall, in its basic format, a cosine function begins from its maximum height. So this is no different, except the shift takes it to x equals 1 instead, and that locates this point. The period, 2 pi over b, so in this case b is pi, 2 pi over pi is 2, means that everything will repeat every 2 units. So the maximum that we just encountered would repeat every 2 units. Good. Then we just recall that maxes and mins are equidistant, so we can locate the minimums by placing them halfway between the maximums. And the zeros, or the median points in this case, are also equidistant from the maxes and the min, so they're always midway between the max and the min points. There we go. So I think that with these points, then you're well set up to draw the graph that we see in blue.